Hello everyone, my name is Toshiyuki Shimizu. I'm leading system development for Fujitsu supercomputers and Fugaku. I'll talk about our collaborative efforts to support AI for ARMv8 and SVE. As you know, supercomputer Fugaku was ranked number 1 in these 4 major supercomputer rankings at ISC 2020 this June. Note that the performance of the benchmarks are 3 to 5 times higher than second-place machines. We would like to utilize this power for AI area also. This is the outline of my talk. First, I'll review our new ARM processor A64FX CPU and its platforms. Second, I'll introduce our collaborative efforts for AI regarding KaiBak just-in-time assembler and ARM C language extension ACLE. Then I'll show benchmark results. Let's get started. This slide shows the design results of A64FX CPU for Fugaku. A64FX is designed for supercomputers. It supports high calculation performance and low power consumption. On the package, we integrated 4 stacks of HBM2 and it allows high memory bandwidth. Integrated TOF interconnect D promises low latency and high injection bandwidth. Special hardware, such as hardware intercore barrier and assistant cores, support good parallel execution efficiency. Note that A64FX supports ARMv8A and Scalable Vector Extension or SVE. The peak performance is 3.3 teraflops for double precision and 13 teraflops for FP16. This slide introduces the supercomputer Fugaku and its variants. Fujitsu is offering the commercial products based on Fugaku. PRIMEHPC FX1000 is the same hardware with the Fugaku and capable of supporting the same software stack, offering the best application performance, energy efficiency, and scalability. PRIMEHPC FX700 is for easier installation and ease of use, utilizing standard technologies like InfiniBand interconnect and open software stack. All these products use Fujitsu-developed ARM CPU, A64FX, and support binary compatibility. This is the system software stack RIKEN and Fujitsu are developing for Fugaku. The software shown in green letters are developed by RIKEN, and the white letters are developed by Fujitsu. Software includes management software, file system, programming environment, and lightweight kernel. RIKEN developed system software are open sourced, so you can utilize them for any platforms, including our PRIMEHPC family. Fujitsu compilers and libraries are optimized for the A64FX microarchitecture, and they maximize SVE and HBM2 performance. AI frameworks are also included. As I mentioned, A64FX CPU supports ARMv8A and Scalable Vector Extension. The peak performance is 13 teraflops for FP16. It can be utilized not only for the HPC but AI also, especially for deep learning. In order to explore the potential of A64FX CPU and Fugaku, RIKEN and Fujitsu signed an agreement of Fugaku AI project. In this collaboration, RIKEN and Fujitsu work for research and development of software infrastructure for AI, which will create the world top-class computer environment base for AI learning, inference, and utilization centered on Fugaku, and accelerate all AI applications. Fujitsu members mainly work for porting and tuning of frameworks and deep neural network libraries, and RIKEN teams support Fujitsu members in many aspects regarding Fugaku. Fortunately, Shigeo Mitsunari, or Helmi, the Kaibiak developer and genius programmer, is providing technical support. Our supercomputers are ready to run deep learning applications with deep learning frameworks and deep neural network libraries. By supporting deep learning on a general-purpose CPU like A64FX, we can evaluate and modify a variety of algorithms of implementation with small effort. And we will have an opportunity to run the deep learning on the largest scalable system, Fugaku. The advantage of running the simulation and deep learning simultaneously is huge, because the simulation results can be utilized to AI training efficiently. This slide shows the software stack of deep learning for A64FX CPU. We are working to establish a modern and powerful AI infrastructure for ARM-V8 architecture. Assembly code descriptions are often used for optimized libraries and HPC applications. Just-in-time assembler, Kaibiak, and ACLE ARM Syn language extension provide support for assembly code description. We use these tools for deep learning software stack to maximize Fugaku's performance. This slide shows software stack of PyTorch as an example, and explain where Kaibiak and ACLE is utilized. We are also working to support SBE for these tools to draw out the power of SBE, Scalable Vector Extension. Our strategy to support OneDNN is to utilize existing OneDNN code as is, as much as possible. OneDNN is developed for x86 and rapidly evolving. It is a good idea that we minimize the porting effort and follow OneDNN's evolution. We support Kaibiak AHUG assembler and develop translator which translate the x86 JIT codes to ARC64 JIT codes, and we utilize this automated translation flow. This strategy can easily share the x86 latest OneDNN implementation with Kaibiak. We should update the translator only when x86 supports new instructions. However, this translation may introduce some overhead. We also need to consider to port some key functions manually if required. To date, we don't see this situation and performance is good. Kaibiak is developed by Helmi. It is C++ header and JIT assembler used in OneDNN and mRuby. We ported Kaibiak for ARM v8a and published as open source software. Here are benefits of Kaibiak. It is very easy to write assembly description. And optimization is effective at runtime. Parameters are evaluated and codes are generated at runtime. And CPU type independent description can be also supported. We developed a AHUG 64 version of OneDNN and published and worked on an upstreaming to the original. The graph on the right shows the performance improvement when we use Kaibiak AHUG 64. We see about 3 times increase. Following 2 slides introduce the benefit of ACLE ARM language extensions for SVE scalable vector extension. It is very easy to use and provides sizeless SVE vector types. This example shows mask register operation for branch. ACLE is free from vector lengths. In another word, portable across different vector lengths, and easy to control effect on inactive mask. We are working on upstreaming our tuned PyTorch with ACLE to original repository. The graph on the right shows the performance evaluation results. The tuned PyTorch performs about 7 times faster than the original for OpenNMT benchmark. Following slides show more larger benchmark results using our tuned software stack. Performance results on ResNet50 and OpenNMT show that performance of A64FX and the latest Xeon CPUs with same number of cores is almost the same performance, while A64FX is about 3 times more power efficient. The performance of ResNet50 on the Fugaku shows good performance scalability. Beyond 10K nodes, evaluation is ongoing. Supercomputer Fugaku became the first supercomputer in history to receive the #1 prize in the top 500 HPCG and Graph 500 at the same time in June 2020. In addition to the top prize in the new HPL-AI ranking, I believe that these good performance in various benchmarks verify our co-design approach for application performance. Fujitsu designed A64FX supports high memory bandwidth and high calculation performance for HPC and AI workload. The results of the primary evaluation of AI benchmarks support the future of HPC and AI. Simultaneous running of HPC and AI will be reality and deliver synergistic effects. Thank you.